Hi, my name is Janis Kuze. I'm representing company SPH Engineering. Today I will present about use of unmanned systems in different industries. To give you an overview how this technology is used right now and where it can go in future. So, about use of drones and different aspects limiting their rapid development. Because currently they are quite known, but there is still big room to grow. Our company is mostly known by UGCS, which is mission planning software for the drones for complicated scenarios where you need to gather data to do analysis and get useful insights. Also, we are only ones who currently provide on commercial basis software to control drone shows. Our newest line is industrial solutions, where we have integrated advanced sensors from geophysics on the drones to speed up the gathering of the data and getting the insights. This is our family of our UGCS software. If you want more information, you can follow those links. But let's return to our topic of today. So we have to start with deciding how to classify usage of the drones in general. I would say that it's best to divide it in two parts, creative and, as I call it, objective. Creative means that it's photography, cinematography, and such creative endeavors where you have to think and their most value is added not by technology, but by people behind the camera, or in this case, behind the drone. We will not focus on that today because that niche is pretty developed and it's not growing that much, or even if it grows, it's not that significant and not that game-changing in all the other industries as objective one. So let's return to objective ones. Objective use of drones. So in this case, drones are used with different sensors, not just cameras. It can be ground-penetrating radars, different multispectral cameras, radio frequency monitoring devices, and other sensors to get the data, which can then be processed with different techniques, new or half a century old ones, like for surveying and mapping. That doesn't matter, but the main aspect is that here drone has to fly and gather data as precisely as possible, so that data can be used later to process it and get useful insights from it, be it visual information or inspections, like detecting defects of power lines or pipelines or buildings. That all can be done with different kind of sensors, and that's objective use of drones. Another big question about how to classify usage of the drones is whether to divide it by industry or by application, because that's pretty hard to answer question, because different sources divide it differently. But I would suggest let's use it as a matrix, because in real life, one application, even like photography from drone, can be used in many industries, be it oil and gas, or inspections, or insurance. All those used for different aims, the same application of the drones. So here you can see like a very rough division between different industries and which applications are used in those industries. And also I tried to, from my own experience, somehow divide whether that's like a very strong use or it's just a marginal use. But takeaway from this should be that in any case, in any industry, any application can find its way to bring more benefits. If not today, then in future. So yeah, if we take some from here, like maps, everybody needs new, better maps to see what are their conditions, what are like conditions, what are like looking their objects, like industrial objects, whether there are some changes. Same goes that with the less popular things, for example, aerial delivery, which is like very hot topic on news, but let's be real. There are a lot of limitations and a lot of problems. So why I, as an industry insider, say that aerial delivery will be very niche and not that popular as somebody who wants to get next investor on board for their startup thinks it will be. So I will leave this slide here. I hope presentation will be downloadable and you can do more research on your own and take a look at it. But now let's move forward. So what are the current limitations? The main problem is that currently by law in many countries we are confined to line of sight flights. That means that you cannot lose sight of your drone once you are doing something with it. That's a really big limitation, and it's a good limitation, to be frank, because you never know what's going on behind the building or if it's out of sight. And clearly, that is one of things which will improve in future. Also, if we are looking from perspective how it works together with other systems. Currently, usually companies come and they order from third party different images from the drones or the data gathered with specific sensors from the drones, or they have their own pilots, but that's not how it should be. Therefore, like limited automation is also a big issue right now. And once we have all that data, we need to get some useful insight out of it. And useful insights come out from analytics. And analytics mostly are done by humans right now. There are some areas like orthophotography where there are lot of very good solutions which can stitch images together and make one single big map or image. Yes, but that's like just one application. Another issue which limits drone usage and getting most out of it is that currently it's like single drone, single sensor, single pilot. There's no yet commercially viable solutions where you drop like 10 drones on the ground, push one button, and here you go. And you in very short time you get covered a large area and get your data for analytics. And also common standards are issue. Data formats, file formats, you can get even the same images in different formats, even if it's like extension is the same, metadata can be different, and therefore you can process it in one software, but you cannot process in another software. So that needs to be improved. And one of the biggest one is fear from the unknown. That's that the authorities and the industries who fear those authorities are generally limited by what they can even use as a proof of concept right now, because yeah, let's be honest, drones are controlled by the same people who are controlling civil aviation, and in civil aviation any error means death. That's not true for UAVs, so that's what needs to be addressed on the authority level about how to ease that once we get past the risk of somebody dying. Maybe just enough of insurance is good enough to proceed. But why it is so? It is so because commercial drones can be commercially viable tool only because they are not that reliable as civil aviation. Because if you will get a drone which is as reliable as manned helicopter with pilot inside, with all the maintenance procedures, with all the certification of even single bolt needs to be certified in helicopter. If you will get the same level of reliability for a drone, the drone will cost much more than a helicopter with a pilot. And that will not bring us a scale which is necessary to get necessary economical benefits out of unmanned systems. That's a very good reason, but that needs to be addressed in a risk management. So we know that nobody dies, but at the same time we don't care that much about property, as we can cover that with insurance. So here are some points which will help to get more out of unmanned systems in future. As I told, very important is to correctly assess the risk. So risk management procedures, which will describe which risks and how will be in each application, in each case, dealt with, what is like probability of those risks and how we can mitigate that, and whether it is so that if not everything 100% is not covered, really that means that we shouldn't even try in controlled environment, like flying over the forest, where damage to somebody is like minimal, even probability is even less. So that needs to be answered to develop unmanned systems in future. Very big question is bay on line of sight. Bay on line of sight flights, because currently you can operate drone maybe 300, 500 meters from yourself, and if you are like monitoring forests, you lose sight of your drone immediately as soon as you fly over the first of the trees. But there's no use in monitoring forest, which is like a very large area, if you cannot fly bay on line of sight. So there have been a lot of proof of concepts in the world. Very few flights have been approved as bay on line of sights by authorities. And the requirements have been really crazy, I would say. Like you have to put an active radar on drone, which is not possible due to weight limitations. Or one company put like audio-based detection system, which detected the signatures of different kind of engines incoming to the location of the drone. But that's such costly, such complicated, that it will never be commercially viable. So yeah, that needs to be addressed with less restrictions, with more tests in controlled environments. Next is automatization. So here goal is that in future there will be no drone pilots, because drone system should be as easily usable as any tool currently used by experts in any field. If it's inspection of the railways, then a railway inspection engineer should be able to just unpack the drone, mark the railway track where he wants to do the inspection, and the rest will be done by software. That's the level what we want to achieve. And also integration with the standard operating procedures in the different industries is a big issue, because they are written for paperwork, for current IT systems, for standard procedures performed by hand. So that needs to be addressed. And where industries come together with the government is to make sandboxes. We, as an industry developing unmanned systems, need sandboxes of different scale, of different objects, of different industrial infrastructure, so we can address that and do tests in safe environments, so later those solutions can be used in real life, in a real industry, and hopefully that will bring us closer to next let's call it version 2.0 unmanned systems in our world. Thank you.